Today we are going to learn the second part of this topic, which is the area of triangles, parallelograms, kites, and trapezium. We are going to learn on how to find the area of all these four types of different types of shapes over here. Okay, so first thing today, what is the first thing before we learn to find all of this? The first thing is we are going to estimate the area of various shapes using various methods. Okay, second thing, we are going to derive the formula of the area of triangles, parallelograms, kites, and trapeziums. Maybe these two or these three are new for you. Maybe you don't know what is a parallelograms, kites, and the trapeziums. I'm going to elaborate further later on so that you understand what are they. And lastly, this part we are not going to involve it yet, maybe in the next lesson. Okay, if we have time, then we are going to finish this part. Okay, let's continue. First thing, we are going to learn how to estimate the area of the various shapes. So I'm sure you have done this before in your science. Okay, various methods can be used to estimate the area of an irregular shape. Okay, previously we learned to find the perimeter, okay, which is the boundary outside the figure. Today we are going to estimate the area, this part over here. So if you look at the figure that we have, to estimate the area of an irregular shape like this, you can put it on a grid line that is of a square of 1 unit, the size of 1 unit over here. Okay, I make it bigger a bit. So this is 1 unit. This is also 1 unit. So it's 1 times 1, 1 unit square. So how to estimate it? Very simple. The box that is filled fully like this, you can see the tick like this, or more than half, they will give a tick. So over here, they already tick the one which is full for you already. Okay, we are going to find out how many of it. And then the one that is more than half, they already mark it as this cross symbol. So the one that is more than half and a fully one will be considered as 1 unit square. Okay, right now we are going to calculate how many number of full 1 unit square. This one, number of full 1 unit squares. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44. So I'm going to write down over here, we have 44 full 1 unit squares. Okay, so now we are going to look for number of half full or more than half full square, which is the one that is marked with the cross. Okay, this one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Am I right? I repeat, 1. I start from here. I circle it so that you can see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10. I'm going to write down over here. Okay. Hence, the area of the shape is about, how to get the answer, you have to add up these two. 44 plus 10.
54.
Yeah, so the answer that you will get is 54 unit squared. Remember this answer? That is to represent the area of this irregular shape over here. Okay, now we are going to try a second method. Second method for this irregular shape also, what you can do is you are going to draw the line which is 1 unit apart. It's different from using the grid line just now. This one we use the grid line. Now we are going to draw the line 1 unit apart. 1 unit apart means the distance over here is 1 unit. Okay, so you are going to draw using ruler all the line until the end of the figure. Okay, now you are going to assume one line as a rectangle with a width of 1 unit like this, you are going to assume it's like a rectangle with a width of 1 unit. So it is simple. Later on, what you do is you are just going to measure the length of the line. Okay, so first one you can see from the table given already. Line 1, this is line 1. Then measure the length. So you will get the length over here. This is equal to 4.4. Okay, and remember, one line, the width is 1 unit. So very simple. To get the area, you just use 4.4 multiplied by 1. We get 4.4. Second line over here, it is longer. Okay, it is longer. So we will have the value of 6.6. And also the rest that you can see are getting longer again. So we will have 7.2, 7.8, 8.0, 8.0 until the end. The last one is the shortest one. This is the one. After that, each of the line will be multiplied by 1 unit. So it's simple. When you get 6.6, the answer is 6.6. When you get 7.2 multiplied by 1 unit, you also get 7.2. So what you need to do to find out the total area is you need to add up all of this. Okay? So after you add up everything, the total area that we will get is equal to 56.4 units squared. Okay? Hence, the area of the shape is approximately. What is the meaning of approximately? No, not. Dalam bahasa Melayu, lebih kurang. Okay, the area of the shape is approximately 56.4 square unit. So you can compare 56.4 with the one that we have earlier. This is 54. They are almost the same. Okay, so this is under estimation. Okay, first part we have done. We already learned estimation. Now, do you have any problem?
No.
No problem. Okay.
No.
Then we continue with the second part, whereby we are going to learn on how to find the area of the 4 types of shapes. So this is the one. I show you the summary of it first, but then we are going to go through one by one later on. So this is the area of triangle, the first one here. For triangle, we have a few types of triangles. You can see this one, the one with the right angle over here. Okay, so you are given the base of the length and also the height already. And then this part, okay, the triangle look like this, but then the vertical line is in the middle. And then this one, the triangle that is slant to the right. Okay, we have a slant height like this. And then you are going to figure out how to find the area of the triangle. Okay, so all the formula for this triangle, the triangle formula over here is the same, which is 1 over 2 times A times B. 1 over 2 times A is the length of base. Okay, you can see the A over here, that is the length of base. The B represent the height. So the B is this part. For this triangle, the B is right here. For the last triangle, the B is here. It must be the one with a 90 degree. Okay? Don't worry, I'm going to go through how to derive the formula of this one later on. Next, you can see the parallelogram. What is a parallelogram? Parallelogram is a figure or a shape that have 2 pairs of parallel lines. So this line is parallel. This one parallel with this. What is a parallel line? Parallel line is a line that will never meet when you extend it. For example, if I extend this line till the end, they will never meet. And then the distance is always the same. So we call this parallel line. If I have a line like this, okay, you see when I extend the line, they will meet at the end. They will meet over here. So this kind of line is not a parallel line. A parallel line will never meet. So over here, when you have a parallelogram, meaning that you have 2 pairs of parallel line. This is the first pair over here. This is the second pair. So you can see when you extend the line, they will never meet at the end. So we called it parallelogram. And then the third one is a kite. We are going to find out how to get the area of the kite, which is 1 over 2 AB. And the last one, this one we called it trapezium. Trapezium is the one with a pair of parallel line. 1 pair only, you can see this one. So the formula will be 1 over 2 times A plus B in bracket times T. T represents the height over here. Okay, so I show you 3 different types of trapezium, not only like this. We also can call this kind of shapes a trapezium because they have a parallel line. This one, parallel, so it's a trapezium. This one also, because this is parallel, we call it trapezium. Okay, now we are going to enter into how to get the formula for each of these. Okay, let's see the first one, the triangle. Okay. Now, if you look at the figure here, there are a lot of wording. We are not going to confuse by reading all of this. Don't have to read all of this. You just need to look at the figure over here. For example, this one is given a rectangle. So if it is cut into 2, we have 2 triangles over here, isn't it? Now, you know to get the area of a rectangle is A times B. Okay, if it is cut into half, we can get the area of the triangle already, which is half of the area of the rectangle. So half AB. So this one is simple to represent the first type of triangle like this. Now, if we have this kind of triangle down here, the second part, this type of triangle. So we are going to go through the C, the rest you don't have to read. The area of triangle ABE, you look at ABE, meaning the one in orange over here. It is equal to what? It is equal to, you can see the length over here, D, this is the length of the base, multiplied by B, because I get it from here, and then it is half of the, something like a square over here. So I can fill in already, it is half of this one is D times B, or B times D, half of B times D. Okay, and then for the other side over here, this is a rectangle over here. The width is C, the length is B. Okay, I write down here, the length is B. So the area of a rectangle, this part is B times C, isn't it? Now I want to get just the triangle. So it will be half of the rectangle. So it is half BC. Okay, so you have learned the distributive law earlier in chapter 1. We are going to apply it here. So you can see this half B, half B, they are the same. So we factorize it out here. Okay, the one that should be written inside is C plus D. Okay, or I write down D first lah. D plus C is the same thing. Half BD, so we get it here. Half BC, so this is the one. Okay, now if you look at D plus C, this is D, this is C. D plus C is actually equal to A. Can you see that? They are equal to A, this one. So we can simplify the D plus C here as A. And then the front part, we just copy down 1 over BA. And that is how we get our formula, because we need to arrange it in order. So it will be 1 over 2 AB to get the area of the orange triangle over here. Okay, which is 1 over 2 multiplied by A, that is the length of the base, this one, already stated up here, A, multiplied by B, that is the height. Okay, so this is the second type of triangle. Now we look at the third type of triangle. This is the one. This is the third type of triangle inside a rectangle. One more time. So you are given the length of the rectangle here is A, this is C, this is the width, this is B, the height. Now, no need to look at all of this. We just look at D here. Okay, look at D. The area of triangle ABE, this one, ABE, so meaning the orange colored here, is equal to the area of triangle AFE. AFE. Can you see the big one here? AFE, the big one, minus the area of triangle BFE, minus the smaller one. Okay, so meanings we are going to get this big area over here. After that, we are going to deduct this part, minus this part. so that we can get the area of the orange triangle right now here. Okay, so it will be 1 over 2b. So you can see from here, we are going to get the whole thing first, 1 over 2b times a plus c. Can you see that? It is half of the triangle like this. So this part is half of the rectangle. So it will be 1 over 2 times a plus c. The a, I get it from up here. Here, a plus c times b. So we already have 1 over 2b. We just need to write down a plus c. Minus what? Minus 1 over 2 times b. So this is b. They already give you 1 over 2 times b. You just need to add on another c. Okay, minus 1 over 2 times bc. Okay, now if we extend the distributive law, so it will be 1 over 2 times ba. So 1 over 2 ba plus this one will be 1 over 2 bc. And then the last one, you just need to copy down, which is 1 over 2 bc. Okay, did you notice something? That they are the same, right? 1 over 2 bc minus 1 over 2 bc, nothing left, no more. Okay, when it is nothing left, so we will get the formula, we can derive it already. It is 1 over 2 ab, just this only, because this minus this, no more. Okay, so you can see all of our formula that we have, it is 1 over 2 times a times b, 1 over 2 times a times b, including the first one. This is also 1 over 2 times a times b. So it is proven that for the formula of a triangle, you just need to memorize. It is 1 over 2 times length of base multiplied by height. This is the one. Okay, that is the area of the triangle. So what you do, you just need to memorize this. Area of triangle is 1 over 2 AB. You just need to remember the A over here, it represents the length of base. The B over here will represent the height. So where is the length of base? This is the length of base. This is the length of base. Where is the height? This is the height. Don't take the wrong one. This is not the height. You must take the correct height. This is the height. For the second figure, this is the height. This one, this is the height. Okay, make sure you take the correct one. So you can see the little cutie over here. It says that base and height are always at a right angle. So to get the height, you just need to look for the right angle. This is the right angle. Right angle means 90 degree. You haven't learned this yet because we skipped 2 chapters before. So I'll let you know right now. This is a right angle. It is 90 degree. Okay. Now we move on to the next one. Do you have any question for the triangle just now? Class? No. Okay, so that one is triangle, a simple one. Now we move to parallelogram. So you can see the parallelogram over here. The formula is very simple for parallelogram. The formula is exactly the same as a rectangle like this. Why is it so? Because you see, this is a parallelogram. Okay, they cut it off this part. They cut off and attach it on the right. So actually, the parallelogram is the same exactly as a rectangle like this. Because for example, if I cut this off and attach it back, it becomes a rectangle. So for a formula, for a parallelogram, it is just A times B directly. Okay, not much thing to proven over here. Okay, so this is the one. The area of parallelogram is equal to A times B. A is the length of base. This one, length of base. B is the height. And you got to remember, the height is always 90 degree. This is the symbol for 90 degree. Okay, you cannot take this. This is not the height. The height must be 90 degree. Okay, so that is parallelogram. We move on to kite. Kite is more or less the same thing. I'm going to simplify fast about kite over here. If you look at your book, you have to fill in a lot of things, but I don't want you to confuse with all of this fill in. You can fill in yourself, you try it out yourself. So what I want you to know over here is, you can see the green colored diagram over here is a kite, isn't it? If I remove the first part here, I paste it here, and I remove this one, I paste it here. So you can see after I paste it, it becomes a rectangle. It becomes a rectangle over here. So this is the part here, which means the kite is half of the whole rectangle. Can you see that?
Yes.
Yes, huh? So simple. You just need to know the formula for a kite is 1/2 times the length of the rectangle A multiplied by the height B. It's also the same as the formula to find out the triangle. Okay, now the A, sometimes it can be tricky. You not really can find the A over here. So the A is actually the diagonal. So you learn this new word again, diagonal. What is a diagonal? Dalam bahasa Melayu, diagonal adalah perpenjuru. Perpenjuru bermaksud garis yang disambung di antara bucu. Okay, I show you. I need a space for that. Okay, for example, if I have a square, we will have two diagonal. Okay, diagonal is the line that join from vertex to vertex like this. So we have one diagonal, we have two diagonal. Okay, that is the meaning over here. So 1/2 AB, A represent the diagonal over here, this part. B represent the diagonal over here. You just need to add them up. Okay, then you can get the area of the kite. Okay, now we move on to the last one. The last one is the trapezium. Still remember? Okay, trapezium also very simple. You can see you are given two trapezium over here. If I turn this one around, and I can attach it to the first figure here, right? I can attach them together. When I attach them together, it becomes a rectangle again. Okay, so over here, the formula for a trapezium, because this is half of it, so we have to use half times A plus B. Okay, why A plus B? You see, this is A right now. This is the one that we turned around just now. This is the B. This is the B. That's why we need to use A plus B for the rectangle. And then you multiply by the height here, the T. I copy from here. So the formula is 1/2. Why 1/2? Because we cannot have 2 over here, because if you attach both together, it becomes rectangle. The trapezium is just half of it. So 1/2 times A plus B, that is the length, you multiply with the T. Okay, so now we look at the figure down here. That is the formula of the trapezium. Okay, the area of the trapezium is 1/2 times the sum of the length of the two parallel sides. So this is the two parallel sides. Okay, multiply by the height. So we will have 1/2 times A plus B times T. Remember, you add the two parallel sides and you add up with the T, the height. Okay, so again, this is flashback for you. Maybe you will ask again, what is a parallel line? That is the line that will never meet. Even when they are extended, they are known as parallel line. Okay, so this one, no matter how long I extend it, they will never meet. They will never meet. They are called the parallel line. So you have to add up the length of the two parallel lines. Are you okay? Can or not?
Yes. Yes.
So how many types of shapes you have just learned on how to find the area? How many types of shapes?
3.
4 types actually, isn't it? The first one is what?
Triangle.
Triangle. The second one?
Parallelogram.
Okay, very good. Parallelogram. The third one?
Kite.
Kite. The last one?
Trapezium.
Yes, very good. So I let you recap back everything. So this is what I have shown you earlier. Okay, I summarize everything. For triangle, the area is 1 over 2 AB. For a parallelogram, the area is just like a rectangle, A times B. Okay, because we can attach this part to the right and it becomes a rectangle. Okay, next one is the kite. It's 1 over 2 AB, the same as the area of triangle. And the last one, the only thing that you really have to memorize is the area of trapezium. It is 1 over 2 in bracket A plus B. This is the parallel line. You see, A plus B. And you multiply by the T. So you can see from here, I enlarge the figure here. Can you tell me from this trapezium here, which one is the A and B? A plus B. Can see or not?
Centimeter.
Which one is A plus B for this one? I want the A plus B only. You just let me know. A plus B is always the parallel line. You can see this arrow, the tiny arrow over here. It means the parallel line. Hold on, I switch on the electric. Okay, so the parallel line is the A plus B. So it is 9 plus 15. This is A plus B. What about this one? Where is the A plus B? You have to look for the parallel line.
10 plus 12.
Very good. Can you see the tiny little arrow here? To get the A plus B, we always refer to the arrow. So they will indicate they are parallel. When they indicate like that, you just need to add 10 plus 12 is referring to A plus B. What about this one? Where is the A plus B?
9.
9 and 4. Okay, this is the parallel line. So to get the area for this one is 1 over 2 times, in bracket 9 plus 4 times T, the 5 centimeter. Okay, now we are going to do some practice. We are going to look at the question in your book first. Let me show it to you. And then do this together. This is the one. Self-practice 10.2b. So write an expression to represent the area of each of the following shapes. We just need to write the expression to represent the area. So first one, I assume the area as A. Okay, for this one, A. What is the area to get the area of the triangle? This one. Formula to get the area of a triangle is 1 over 2 AB, isn't it? So it will become 1 over 2. The A is what?
M.
Yes, very good. The A represents the best here. And then, you see how? The N will be the height. So it is 1 over 2 MN. Okay, now we look at the parallelogram. Remember the parallelogram, the formula is A times B straight away, right? So now they represent it using other variable over here, just to test your understanding. So how to get the area for the parallelogram over here?
K times T.
Very good. It is KT. K times T, KT. Okay, the next one. This is what?
Trapezium.
Yes, trapezium. So the area for a trapezium is 1 over 2 in bracket. What plus what?
P plus Q.
Very good. P plus Q. What is the height?
It's R.
R, correct. And the last one, what is this shape?
Kite.
Kite, very good. So the area to get the kite is 1 over 2 times
ST.
Yes, very good. ST. Okay, it is very simple only. Now we are going to solve the problem here. You see, calculate the area of each of the following shapes. Okay, I have to lay down now to write later. First one, area of a triangle here. So you're given the length of the base is 5 centimeter and then the height is 4 centimeter. Okay, so we can get the area already. Area is equal to 1 over 2 AB, isn't it? So it is 1 over 2 times the base. The base is
5.
5, correct. The B is
4.
4. And you simplified it. So when I simplify, 2 times 1, 2. 2 times 2, 4. So I will get the answer of 5 times 2 equal to 10. And you follow the unit given. The unit is centimeter. So area will be centimeter squared. Okay? Any question?
No.
No, huh?
No.
Now we move to this one. What is this?
Parallelogram.
Yes, everyone read after me. I know it's very hard to read. This is a parallelogram. Everybody read. Parallelogram. 1, 2, 3. Read.
Parallelogram.
Yes, one more time. Parallelogram. Read.
Parallelogram.
Yes, good. Okay, I know it's very hard sometimes because this is the first time you are encounter this word parallelogram. So you need to keep practice to pronounce it better. So parallelogram will have two pairs of parallel line. This is the one. Okay, we can get the area just like the rectangle. The area of parallelogram is
AB.
AB. So the A is 6.2. You multiply by 3. So 6.2 multiplied by 3. 3 times 2 equal to 6. 3 times 6 is 18. So the area is 18.6 square centimeter. Okay, make sure you put down the unit. Put down the unit. Okay, next question. Trapezium. So we are going to solve the trapezium here. Formula for area of trapezium is equal to 1 over 2 A plus B times T. Okay, so we just need to replace everything. 1 over 2, still the same. The A is the?
5.4.
Okay, A is either 1, 2 plus 5.4. A is 2, B is 5.4. And the T is equal to? 3. Remember, this is the 90-degree angle. So this is the height. We cannot take this one. This one is not the height. So we have to multiply by 3. And then you are going to calculate using your calculator. So I simplified it here. 1 over 2 times 2 plus 5.4 is 7.4 times 3. So when you calculate using your calculator, later on, 3 times 4, I make it easier. 3 times 4 is 12. 3 times 7 is 21. Plus 1 just now, we have 22.2. So it is half of 22.2. Then we are going to get, how much is half of 22.2? 11.1 square centimeter. Okay. Next question, D. Okay, we are almost reaching the end. This is what?
A kite.
Kite, very good. So we are given the length over here. What do you call this? From vertex to vertex? Still remember the name that I told you just now? This is the diagonal. How many diagonal do we have here?
2.
Yes, very good. This is 1 diagonal, this is 2 diagonal. And if you look at the sign over here, they mark it like this. They mark it like this, meaning they are the same. So if that is 2, for sure this is 2. And then if on the right is like this, a kite must be balanced, isn't it? So this is also 2, although they didn't put it down. Okay, now we are going to calculate the area for the kite. The area is 1 over 2 times, still remember we have to multiply A, B. So the A is the diagonal right now. It's up to you how you want to put it in. The A can be this one or this one, up to you. So I assume this is the A. How much is the A? It is 2 plus 2. Okay, and then the B, this is the B. It is 3 plus 2. Yes, so we simplified it. It is a 4 times 6. So here I can simplify by using cancellation. 2 times 1, 2. 2 times 3, 6. After that, You just need to multiply 4 and 3. 4 times 3, how much?
12.
12, correct. 12 centimeter. Okay, 3 plus 2, 2 plus 2. Yeah, do you have any question? Sorry, I made mistake over here. 3 plus 2 is a 5. Sorry. So we cannot simplify this part over here. Okay, I redo this part. You didn't correct me when I say 3 plus 2 equal to 6. Okay, this part remains the same. This is a 4. 3 plus 2 is a 5. So our cancellation, we only can simplify on the first number. So this part, 2 times 1, 2. 2 times 2, 4. Okay, now what is the answer for 2 times 5? 10, correct. So the answer is 10 squared centimeter. Do you have any question?
No.
So you need to memorize this formula. Although it is given in the exam, the formula will be given. But to make it fast for you to do your calculation later on, you just need to memorize. Very simple. Area of a triangle, 1 over 2 AB. Area of parallelogram, A times B. Area of trapezium, 1 over 2 in bracket A plus B times T. And then for the last one, the kite, also the same as the triangle, which is 1 over 2 AB. Okay, now we move on to the last part here. We can enter the problem solving today. So you look at the question given, the mathematics zone, this one. The diagram shows a rectangle plot of length PRTV. So when you are reading the question, you've got to refer to the diagram PRTV. So this is the rectangular plot of length. The triangular region PQW, look for PQW, this is the one, PQW, and the trapezium shape region UTSX, this one, UTSX, this is a trapezium here, are used for planting banana trees and rambutan trees respectively. So this one is for banana tree and this one is for rambutan tree. The remaining shaded region is used to plant papaya tree. So in this part here, they planted the papaya trees. Calculate the area of the region used to plant papaya tree. So you just need to calculate the region over here, the shaded region. To do that, you just need to remember, you just need to start from the simplest working. How to get this shaded region? You are given the whole rectangle, you just need to minus the triangle, minus the trapezium. Then you get the area of the shaded region. Isn't it? Understand or not?
Yes.
Yes, huh? So what we need to do is we are going to find the area of the rectangle. After that, we are going to find the area of the triangle, the trapezium, and we are going to use the rectangle to minus both of them. Okay, so firstly, we get the area of the rectangle. So area of rectangle, we have the name already, which is PRTV. Follow the alphabetical order. Okay, area of PRTV is equal to length times width. The length, this one is 4. It's not complete. So we are going to use this part. 4 plus 12 is 16, isn't it? Multiply by the height over here or the width. The width is 10 over here because 5 plus 5 is a 10. So 16 times 10, we get 160 meters squared. Okay, why meter squared? Because the unit used is in meter. Okay, now we are going to get the area of a triangle. So the name of the triangle is PQW. Okay, the formula is 1 over 2 times base times height. So it is 1 over 2. I write down for you. Later on, you don't have to show this. Just to let you know, the A will represent the base is 4. Okay, and the height is 5. So you simplified it. 2 times 1, 2. 2 times 2, 4. The answer for 2 times 5 is 10 meters squared. Okay, I wrote too fast already. 10 meters squared. So we found the second one. Now we need to find what?
Triangle.
Area of, this is
PQ.
trapezium. Okay, S-T-U-X. Trapezium, huh? So the formula for trapezium, I write down first. 1 over 2 A plus B times T. Okay, so it will be 1 over 2. What is the A? Yes, very good. You determine the parallel line. This is the parallel line here. So it is 3 plus 4. The T is 5, correct. Then we continue. 3 plus 4 is a 7. And then times 5. So the easier way to solve this will be 7 times 5 is 35. So half of 35 will be 17.5 meters squared. Are you okay?
Yes.
Yes, huh?
Yes.
Okay. Lastly, we need to calculate the area of the region that is used to plant the papaya tree. So you can get the area already by deducting both the shape. Area of the region used to plant papaya trees. Okay, I move it up. Is equal to the area of the rectangle, which is 160. You minus the triangle, which is 10. And you minus the trapezium, 17.5. So 160 minus 10, the remaining is 150. 150 minus 17.5, you will get 132.5 meters squared. Okay, so we have done the problem solving. You understand?
Yes.
Yes, huh?
Yes.
Okay, since you understand already, I just want you to see on how to solve the next example. We are not going to solve the problem anymore. You just need to let me know how are you going to retrieve the area of the shaded region. Like this one just now, to get the area of the shaded region, we use the rectangle. I want you to tell me it's rectangle minus the triangle minus the trapezium. So I have two shapes over here. The first one, you can see this part over here is look like something square, maybe. We don't know yet. You have to determine it. So can you tell me how to get the area of the shaded region over here? Let's see whether this is a square or not. This is 16. This is a 10. This is an 8. But we need this part over here. So let's see, this part. If that is an 8, this is a 4. This should be a square. Okay? A square. So can you tell me how to get the area of the shaded region? P area of PQRS minus what? Minus what? Or my question can be like this. How to get the area C? Area of C, the one that is shaded. It will be the whole diagram minus what, class? Minus area A and minus area B. Okay, area A you can see is a trapezium. Area B is a rectangle. Then we can get the shaded region already. Okay, now if you look at this figure here, we have two shaded regions. Can you tell me how to get the area of these two shaded regions? Can or not? Always use the whole diagram. Make use of the whole diagram. It will be area of PRST. After that, minus the area of unshaded region. The unshaded region is VWU, is a triangle, and also QRW. Then we can get the area of the shaded region already. Okay, can you make your thinking more systematic like this?
Okay.
Cannot. Always use the whole diagram, deduct the rest which is unshaded. Then you can get the shaded region. You see the whole diagram, you deduct the unshaded one, you get the shaded region. Okay, same with the question that we have just now. We want to get the area of the papaya, length, this length, the area over here. So use the whole diagram, deduct the triangle, deduct the trapezium. Then you get this part. Or else it's very hard for you to get the area over here. How are you going to calculate this? You need to divide it into a triangle maybe, or a rectangle. So you need to calculate this plus this. And then this part you need to divide again. Get the rectangle, get the triangle. So it is tedious for you to get all the area by adding one by one. Okay? Therefore, it will be easier for you if you use the whole diagram. You deduct the rest that is unshaded. Do you understand, class?
Yes.
Yes.